Hello everybody and welcome to a new experiment. This time, well, it's not that much of an experiment, but it's more a curiosity that I had. What's inside a rectifying bridge? I had a burned rectifying bridge that you see here already dismembered, and I took it apart and look inside it, and I didn't see much, but I did learn something about how this component is made, this type of component is made, and it's pretty interesting. You'll see it's interesting as well. What we have here, we have a plus pin. It is the longer pin that is have here. Is also having a cut in the material, in the shape of it, and the minus pin is bended like this, and in the middle is the alternative current, and on the sides are rectified current, plus and minus. And I put a sticker, a piece of paper, and I stick it. Is mirroring the exact same side. As you can see, is the cutted side is, and the longer pin is the plus, the bended pin is the minus, and in the middle is the alternative. And I did it. I turn it down, with the face down, because it's easier to see these contacts and these drawings that I did here. This is a typical diode that we have here, and I will measure it to show you. You can see it there as well. Yeah, it's good. This diode that I have here is having the marking on the right, as you can see, and it is the same marking that we have here in the image. I put the plus probe, which is the red, in my hand, here and here on this diode, and you will see a forward voltage of 500 millivolts. So this is half of a volt forward voltage through this diode, and typically a forward voltage, it means the minimum voltage that a diode is letting pass through it. So is letting 500 millivolts minimum when it is said that it is opened. The diode is opened, letting the minimum of 500 millivolts through it. 500 millivolts or 0.6 through 0.8 volts are usual through a rectifying diode. And I showed you here because this is the plus, this is the minus, is exactly as like this, and if we are turning it, the other side is not letting pass anything through it. How I cut this component, it's an interesting story. It's the same size, is the same component that we have here. The only difference between the two are the pins. This is having the pins round, like a wire, but these are like flat. That's it. But the inside is the same, and this is brand new, and this was burned from a board, and I put it aside, and now I took it apart. If you can see on the good component that I have here, let's see if you can see anything. It's having a thicker side here and a smaller side here. and that smaller side, which is the face of the component, I grinded it off until I reach the copper contact, this guy here, and from on this side. But underneath, where the thicker side of the component is, are the actual contacts, and also the diodes inside it. I had to guess which side, if the thinner or the thicker side is holding everything. When I had to guess the thinner side should be not that important, and I was right. And this is the diode actually inside it, and let me 1 second to lift this light up and focus. All right, excellent. So this is how it's looking inside. This is a little circle of silicon, and here deposited on a small track of copper, and on the other side is another silicon deposition in shape of the square, and this is it. This is the diode inside one diode, and it has four diodes, and you can see them here as well on this drawing. Let me show you the grinding well, because it's having two grinding wheels, and this is more coarse, more grippier, and this is more finer, and it helped me. That is the dust from the component, and yeah, that's it with the grinder. And what I did here, I drew exactly the same thing that I have in reality. I'll turn it back, because you must imagine everything that you see here is actually flipped. This is like an F. You see, like the letter F is actually here. This F here, so it's pointing like that in here. But if I'm turning it, it's pointing like that. You get it, because here is the silicon on the other side. And this is actually the face of the component, which in reality is the back of the component, because this is the back, is the thinner side, and I took it off, and on the thicker side here, in the fatter side, is the diodes and the contacts and the silicon and everything. And it was a very good guess that I did. I never opened a component like this before. This is the first time. So this is a close-up on the actual elements of the rectifier bridge, and the F letter that I told you is like this. Is actually this here, which is inversed right now, because it's facing up exactly like in this position. How this rectifying bridge component is facing right now is facing up from the base on the table. It's facing up, and this is how it's looking inside. So inside right now is looking like this, okay. But if I'm turning it with the component face up, with the markings on its face, is actually like this, exactly like the letter F, and is fitting here. Here is is the fitting of it, and here is the leg outside, and this the other side of the component is here, is fitting here, so like this, okay. And is the same here but inverse, because this is with the bottom up, and is exactly this two are exactly with the same face up, or in the same side. So this on this side is like this. This element here, this one is like this inside it. So yes, that's all the clarifying the clarification. I've also checked if this leg, if this component is having copper legs, and I'm not sure how good you can see it, but is having copper legs as well, which is very good. Is brand new and very quality, very good quality. So here, back to the explanation here. What I did, I draw the same shapes that you see here, but I also marked what is having on them. So this is a circle, a square and a circle, a square and a circle, and a square and a square. And here is having a little marking as well here. But originally I thought it's a square, but after I draw the actual circuit here, it turned out it must be a bridge, an isolation bridge, and probably there was a plastic bridge for the wire to jump over it, not to make contact, because if it's making contact it will blow up. And also you can see the markings that I told you before, the circle here, circle and circle. Actually they are smaller squares probably, but I didn't see them very well at that time, and I said they are like circles, and in a sense they are pretty much like a little circle, a smaller circle than the larger square that you see here. It's visible more larger here. So it's two circles here, one square and one circle here, one square here, and one circle here, and two squares here. So this is the order, and this is how I managed to figure out the shapes and also the polarities of the diodes, and also between. So let me back down. So between this circle and this square, it's actually the diode. The diode is this black markings are the silicons. So this is the circle, and this is the square, and on top of them is this shape that I showed you in the beginning. It's a copper shape, yes, like this, and is bridging, is making the connection between these two shapes, these two silicones depositions. These black squares are silicon depositions. So and underneath is the metal. So between the silicon, if this is the silicon, on top of it is having a copper plate bridge, actually, that is bridging two silicon shapes, a square and a circle. So this is the silicon, and this is the bridge made of a piece of copper, and beneath is the leg, which is also made from copper. So this is the entire philosophy, idea, and constructions behind all of this. I think it's fascinating, and it's very nice. It was a very good idea to open it up and to the curiosity was about how it's made, but I kind of go out of town with the polarity and how it's actually measured and the sense of the diodes. So it got a little bit complicated. It shouldn't, but it did. And this is the diode here. So I'm drawing the symbol of it. So this is the plus and this is the minus. And here on the image itself, the squares are the plus, the positive, and the circles are the negative, minus. And this is plus, plus, this is also minus here, and minus and minus. I forgot to put this notation before, sorry for that, but I'm doing it now. So a diode basically is comprised from a circle and a square drop, and then metal pads, metal, and on top of these drops of silicon is another metal. I hope it makes sense. So like this is metal copper, this is metal leg, another metal leg, and those two drops, and this is plus, positive and negative, and is actually pointing like this from positive to negative when measured, but in reality when it's not measured with the probes is all the signs are inversed. Is making sense in the circuit when you power it and you use it, but especially for alternative. See, there's D1, D2, D3, and D4. Those are also diodes, and they are disposed. They are arranged in a rectifying bridge format, actually. And here is the alternative. If you look on a rectifying bridge, and this is the IC pins or connections, and here between the diodes is actually the AC marking, So AC marking 1 and AC marking 2 here, and here on this dots is a common, actually. This is a common negative and this is a common positive, which means a single pin basically. If you put a bridge rectifier component inside here, it will work exactly as these diodes here are pointing. This is a new clean sheet. So if we have rectifying bridge here, if we are bridging if we are connecting this and this, and I don't know, somewhere here and somewhere here, we are connecting this to this and this to this, it will work. These diodes, by the way, are flyback diodes, and they're used for the windings of the motor, not to create spikes that will destroy these transistors, which in our diagram here are MOSFET transistors type. They will blow up. If not, protective diodes will be in this configuration that we see here. So this is a H bridge using a rectifying bridge inside it for protection only, and it's very good and workable. And I actually have two rectifying bridge cases. They are made different. One, like you've seen already, but another one it's a semi-D, and is like a little chip like this. And I don't remember exactly. Yeah, I think it is. It's having a positive and negative on one side of the pins and the alternative on the other side. Actually saved by us very elegantly using a semi-D rectifying bridge. I don't remember its name, but you can find any kind of rectifying bridge. I used this semi-D one because it's very tiny, it's very little, and is doing the job exactly as these normal diodes will do. So only for protection, and it's absolutely fine. And I'm showing you this because this is another way of using a rectifying bridge. It's using the case marking that is having, and in this case, if you connect plus to plus, positive to positive, and negative to negative, it will actually work as it is configured like this, but not as I describe it, but not as I measure it. That's the big deal, and it's a bit weird. And this is the if you see it like this, it's not helping, because here is the minus and here is the plus. But if we are turning it back, it's having sense, and this is how it actually is exactly like you are seeing it here, with its back up, and the plus is like this, and this shape, and the rest are like this. Okay, and this is the circuit inside. I measured everything, and this is a normal single diode, like this, and is having the plus side, which is anode, and the minus or negative side, which is the cathode. And I measured it already, and here is the same, but it's not the same. This is a little bit of a problem or confusion. As you can see, I put the markings of the diodes here are pointing from minus to plus, and it should be inverse. As you can see here, this is the plus and here is the minus, and the diode is pointing in that direction. This is the only problem in the rectifying bridge. How do I get which is minus, which is plus? This is how I get it. I measure it. So if this is, if I put like you are seeing here, okay? So if I'm putting, this is the marking here. You see the marking, and here is the marking. It's pointing in the same direction as the drawing. And if I'm measuring, yes, now it's working. You see, so the probes are correct. Okay, I'm pointing correctly, but putting it here and here should work, correct? So you see, if I'm putting it here and here, it's working. So from plus to minus, and if I'm putting it like this, from plus to minus, is working like this. But actually this is minus. So I'm putting the probe here and here. It should be like this, here and here. You get my point? You get my what I'm saying? So if I'm switching and if I'm putting the probes like it should be, from plus to minus, from plus, so here is the plus to minus, and plus to minus, like this, nothing works. Okay? Okay, so now let's inverse and put the plus here. You see? I'm putting the plus probe on the minus and the minus on the plus, and I get, this is actually the third and here is the second. So this is like this, and I'm getting 500 millivolts. You see? Hoppa. So I'm getting 500 millivolts, the forward voltage, and here this is the first connection here, and the second pin. This is the second pin, and this is the third pin, the top one. And I also I'm having 500 millivolts, and also here I'm having double, because these two diodes bridging on this pad here, that pad there, and I'm having double of 1 volt, actually 1000 millivolts, or 1 volt, and it's inversed from a normal diode that we have here. I believe the markings not on my component, on all the components there are out there, on all the rectifying bridge are, it should be plus here and minus here. It should be inversed, but I don't know. I'm not the one to judge anything, so I'm just pointing out my observations. So this is the weird side of things, and it should be, this is the A side, it should be like this, the B side. It should be like I'm putting the plus here like you see me, on this side and pointing towards the minus. Okay, this plus towards the minus and plus towards the minus. I know it's a bit flipped, but yeah. But this is the correct. The A is the correct sense direction. Exactly how it is inside here, and this is how I figure it out. Which element is positive or negative, if the square is negative and the circle is the positive. This was the way of figuring it out. And here is a schematic of a rectifying bridge, and all the rectifying bridge schematics are and also the component itself, they are showing the same representation from negative or minus pin to all the current is flowing toward the plus or the positive pin of the rectifying bridge on one side, and on the other side, in the lower side, is also flowing the current from negative towards the positive. Yes, it's going to the positive. In the middle are bridged the alternative pins or wires, and is exactly what we have here. But it should be inverse. It should be from positive to negative, from a measuring perspective, and not from the component marking perspective. The component marking perspective is correct actually. When you put it in the circuit, the plus side is correct and the negative side is also correct, is flowing from the positive towards the negative, exactly as in diagram showed here. But from a measuring perspective, when you actually measure and probe all those diodes inside this rectifying bridge component, the signs are inversed. So that's a very weird phenomenon. It's logical, but it's not correct. It's not entirely correct. It's very logical, but not entirely correct. So, or not entirely intuitive, you know? All right. Something is weird in the translation somewhere. I'm not sure where, how, and why. But you've seen me doing the actual the reading with the multimeter here, and you can see I'm right. Pretty much this is it. It was a curiosity how this component is looking inside, and I satisfy my curiosity. I hope I satisfied your curiosity as well. I think you learned something today with me, and this is actually the 6th movie, because I had some very bad luck with making the movies until now, and yeah, it took me a while until I made it up, as you see it. So yeah, I hope you like it. Leave a like somewhere, I suppose, and yeah, tell me your impression. And why is this phenomenon of inverse polarity on the components? And yeah, thank you very much for watching, and see you later, I suppose. Goodbye for now.